Hello, everyone, and welcome to the first advanced session of the Mastery Mentors. In today's lesson, we're going to be covering divisibility rules, greatest common factor, least common multiple, and prime factorization. This video is for those who missed a lesson or want to look over what was done in the lesson, so it's not going to be fully comprehensive of every single problem, but we are going to hit all the main points and do a few practice problems to ensure understanding. With that, let's get on with it. I just want to emphasize that this is a review lesson focusing on topics that you should already know, and the classes that we will be having later on do not match the difficulty of this one. This one is simply to make sure you understand how classes work and have a solid foundation for what's to come. Now, these are simply some warm-up problems to get your mind warmed up. You're welcome to skip these if you'd like, or pause the video, write them down, and work through them. So this is the first two, and here's the second two. The answers are here. I'm not going to be explaining these as these should be very knowledgeable topics for all of you, and this is, again, more so just to get your mind warmed up. Here's some vocabulary that if you do not know already, then I'd totally recommend pausing down and writing down what you don't know. And for most of you, I would also recommend writing down the GCF LCM formula. It's not as commonly taught in school, and it's more so useful in competitive math, such as math counts. And we're going to be using it a lot in this lesson. Additionally, this is sort of what's going to make this batch advanced. So we are going to be learning more than the other batches in that you will be learning different formulas, strategies, and methods in order to speed up your problem solving process. So feel free to pause the video and jot these down. So firstly, let's start off with prime factorization. Prime factorization, if you didn't know already, is when you break down a composite number into a set of prime numbers that, when multiplied together, should result in the original value. As you can see, there's an example right here of 12, which can be written as 2 times 2 times 3 or 2 squared times 3. I recommend this notation for our lesson as it's easier to understand what comes afterwards. Now for divisibility rules. I assume that we all know number 2, which simply is determining if number's even. Number 5, number 0. Those three are all very common. So I'm going to be going over the other ones. 3 and 9, I remember very similar as 3 squared is 9. And I always find it interesting how this one works out because if you add up their digits and it is divisible by 3, then the entire number is divisible by 3. And it's the same thing for 9. Additionally, if it's an especially large number and you add it up and you're still unsure if it's divisible, then you can add those up as well. As for 4 is very similar to 8 in that 4 involves checking if the last 2 digits are divisible by 4, and 8 involves checking if the last 3 digits are divisible by 4. While this isn't always uber efficient, taking 2 digits over 4 or 6 or 8 is always a lot more preferred. As for number 6, just remember that 6 divides into 2 and 3, so the rules for 2 and 3 have to be satisfied for 6 to work. Finally, for 12, just remember that 12 divides into 3 and 4, so both rules 3 and 4 have to be satisfied for 12 to work out. Greatest common factor. Now, greatest common factor up until now has oftentimes involved writing out all of the factors. However, prime factorization is a faster method, so I'm just going to use the example of 12, 20, and 24 to show. Let's take 12, and I'm not going to be drawing out the entire tree for time purposes. You're welcome to try them out on your own if you'd like, but 12 is equal to 2 times 3, as we found out earlier. So we're going to be writing this as 2 squared times 3. You'll see why in a minute. 20 would be 2 squared times 5. And the third number, 24, is 2 to the third times 3. Now, the method for determining GCF, you have to take firstly you have to find the shared numbers that there are. While it looks like 3 is shared, it's only present in 2 of the 3 cases, so we can't use 3 or 5. 5 only appears once, and 3 only appears twice. So the only number we can really use is 2. Then we have to use the smallest power, and out of 2 squared and 3 squared, 2 is the smaller power, 2 squared is the smaller power. So that tells us that 2 squared is our GCF, or in other words, 4. Now, LCM uses a similar concept. However, instead of using shared factors, you will have to use all of the factors to its highest value. So as we can see here, Take 12 and 18. 12, as we've already established, simplifies into 2 squared and 3. And 18 can break down into 2 and 3 squared. Now, out of 2 squared and 2, 2 squared is the larger power. And out of 3 squared and 3, 3 squared is the larger power. So, you would multiply them and give you the final answer of 36 as your LCM. Here's another example that involves 3 numbers, like I showed earlier. However, it doesn't matter as much because you don't need the numbers to be shared anymore. So 24, 36, and 40. Now out of all of the 2's, 2 to the third is the greatest power. Out of all of the 3's, 3 squared has the greatest power. And because there's only one 5, you have to use that 5. Multiply 2 cubed, 3 squared, and 5 to get your final answer as 360. Now for the GCF LCM formula, the more advanced part of this lesson. The GCF LCM formula says that two numbers multiplied together is equal to their GCF and their LCM multiplied together. This is more so useful in competitive math, but you can also use it to speed up the process in normal math classes. So here's the first problem we're going to be working on and this focuses more on divisibility rules, so we're not going to be spending too much time on it because, again, most of this should be very much review, but I'm just going to work through it very briefly. So our number is 481,500 in K6. In this case, 2 doesn't really help us much because we already know that it's even due to the number 6 being at the end. So I'd say whenever you've got to test for 3, 9, and 4, 3 and 9 are going to be the most useful because they're very quick to do, but they also help you figure out exact numbers due to having to add up everything. So for 3, we know that 4 plus 8 plus 1 plus 5 plus 6 plus k equals 2. Now, let's say this k wasn't here for a second. This equates to your final answer of... One second, let me just change this to a colon to make things easier to understand. Your final answer of 24. And obviously 24 is divisible by 3, but theoretically you could add these and get you your final answer of 6, which is also divisible by 3. However, the issue here is 9 has the same rule, and 6 is not divisible by 9. It's important not to forget we had a plus k here. So if this plus k was a 3, this would give us an answer of 27. And if you didn't know the 27 is divisible by 9, you could add 2 and 7, giving you your answer of 9. Telling us that the likely value of k is 3, as that's what makes both 3 and 9's rule satisfied. 2 still stays satisfied due to this 6, so all that's left to check is 4. In case you don't remember, 4's rule is the last 2 digits have to be divisible by 4. So 36 divided by 4 is 9. It does divide evenly. So the answer would be 3. This next problem uses the GCF LCM formula I just taught. So suppose we have two numbers m and n such that mn equals 1260 and the least common multiple of mn is 210. Find the greatest common factor of m and n. Now normally there would be a lot more work you would have to do, but thanks to this formula, it's just a simple division problem at its base. So what you would do is you would firstly write out the equation. Mn is equal to LCM Mn times GCF Mn. Now, multiplied, we know that this is 1260, and we know that the LCM is 210. And solving for the GCF. So now all we have to do, really, is divide. And this is where your paper is going to come into play. Make sure you use your paper to its best extent, especially when you have time. Mental math is excusable when you don't have so much time left, but try to use it as often as you can to make sure you're as accurate with your problems. So this you would divide out on the paper to get your final answer of 6. Now, this is going to be we are going to be just doing a few more problems. So our next problem is going to be number 3, which is the ratio of the least common multiple and the greatest common factor of 180 and 594. This is going to take a minute, but that's solely because all we have to do is prime factorize. This is going to go a lot faster on paper. So 180 simplified into 3 and 60. Simplifying numbers into less complex, such as using 3 instead of, say, 36, allows you to divide a lot faster and a lot more certain. This divides into 3 and 20, and you would simply keep going until nothing is divisible anymore. So 3 obviously is prime, so you can't divide that any further. This divides into 4 and 5, and then it's important to remember 4 divides into 2 and 2. Giving us our final prime factorization of 2 squared times 3 squared times 5. Similarly, over here, if we were to do the same for 594, we would take this 594, and again, make sure that you use your paper whenever you need it. So dividing this into smaller numbers really does help. 2 and 297, and while 297 may appear prime just by the way you look at it, it's important to remember divisibility rules here. So 2 plus 9 plus 7 equates to 18, which is divisible by both 3 and 9. So you can divide this into 9 and 33, which from there can be divided into 3 and 3. And 33 obviously could be divided into 3 and 11. It's giving us the final prime factorization of 2 times 3 to the third times 11. All that's left to do now is calculate the GCF and LCM. So let's start off with the GCF. If you remember, GCF requires shared numbers, so 5 and 11 are immediately out of the picture. Between 2 squared and 2, 2 is the smaller power, and between 3 squared and 3 cubed, 3 squared is the smaller power. 3 squared is 9, so we find out the GCF is 18. LCM obviously is going to require a bit more math, so LCM would be, we would start off with 2, and between 2 squared and 2, 2 squared is the larger power. Between 3 squared and 3 cubed is the larger power. And then, because there's only one 5 and one 11, you would only use one of each. Simplifying helps a lot here, so 4, 9, and then also rearranging to make multiplication faster. So, for example, instead of doing 9 times 5, you would do 4 times 5, giving you 20. Then that could be 20 times 9, which you know is 180. And then 180 times 11 is the only one where you actually have to do any math, giving you a final answer of 1980. But remember, the question asks for the ratio between the two. So you would divide 1980 by 18. Feel free to work this out, but the final answer would be 33. Next up, the prime factorization of 117. This one is going to be a lot more simple compared to what we've been doing this entire time. So what we're going to do is we're going to take 117, and nothing looks immediately divisible. We don't see any even numbers, any divisible by 5. So we're going to be adding, and 1 plus 1 plus 7 gives you 9. So we already know it's divisible by 9, and dividing it out, we find out that it's 1. It's 13. And 13 is a prime number. You're welcome to check that right when you get it. I always like to check to make sure prime numbers are prime just to be entirely sure. And this divides into 3, 3, and 13. So your final prime factor is to be 3 squared times 13. Or 3 times 3 times 13. Now, this mock countdown round was more so for people in class. And every time you join a class, what we're going to do is we're going to be using Buzzin Live. So you're going to go to Buzzin Live, and I will create a game and have a certain code up. So what you're going to do is you're going to open up the link, hit join, type in the game code, which in this case is 736955, and your nickname. So I'm going to type in Aura and join. Now, I'll show a problem on screen, You work through it on your own, and once you have the answer, hit buzz. It'll show me who buzzed in order, and then I'll call on them to answer the question and explain how they did it, and if you do it correctly, you get a point. So that's sort of what our classes will look like, what concepts look like, how we're going to be working things out, and I hope this helps. I'll see you all next Friday. Have a great rest of your day.